Hello dear students, in this video we are going to learn about electromagnet with the help of activity 14.6. In this activity we have to take 75 centimeter long piece of insulated flexible wire and an iron nail about 6 to 10 centimeter long. Okay. Now wind the wire tightly around the nail in the form of coil as you can see in the figure. So figure 14.9 shows the circuit which we have to prepare for activity 14.6. Okay. Now place some pins on or near the end of the nail. Okay. We have to place some pins like as you can see in this picture. These are the pins which are kept near the iron nail. Okay. Now we have to switch on the current. So we will observe the pins which are kept near the iron nail will get attracted towards the iron nail, towards the tip of the nail. Okay. And when we switch off the circuit, the pins will not be attracted towards it. Okay. So the coil in the above activity behaves like a magnet when electric current flows through it. Okay. When the electric current is switched off, the coil generally loses the magnetism and such coils are electromagnets. Okay. The iron nail will start behaving like a electromagnet. Okay. Because the coil of wire is wrapped around it and which is connected to the switch and the battery, and when we switch on the circuit the pins are attracted towards the nail, and when we switch off the circuit it loses off. Okay. The electromagnets can be made very strong and can lift very heavy loads. Okay. We have already learned that in chapter 13 of class 6 that end of a crane has a strong electromagnet attached to it, and the electromagnets are also used to separate magnetic material from the junk. ओके आपने बच्चों क्लास 6 में चैप्टर नंबर 13 में पढ़ा था कि एक क्रेन जो होती है जो जंक यार्ड से मैग्नेटिक मटेरियल का सेपरेशन का काम करती है, तो जिस एंड से वो जंग को सेपरेट करती है उस एंड में एक बड़ा सा मैग्नेट लगा होता है जो सिर्फ मैग्नेटिक मटेरियल्स को बाकी के जंग से सेपरेट करने का काम करता है। जो मैग्नेटिक जंक होता है वो उसमें चिपक जाता है और वो उसको उठा के अलग सेपरेट कर देता है क्रेन के थ्रू। ठीक है। सो द इलेक्ट्रोमैग्नेट्स आर ऑल्सो यूज टू सेपरेट मैग्नेटिक मटेरियल्स फ्रॉम द जंक। डॉक्टर्स भी बच्चों ये यूज़ करते हैं इलेक्ट्रोमैग्नेट जब हमारी कुछ भी छोटे छोटे जो मैग्नेटिक पार्टिकल्स अगर हमारी आई में गिर जाएं तो उनको आई से निकालने के लिए। ठीक है। So doctors use tiny electromagnets to take out small pieces of magnetic materials that have accidentally fallen in the eye. Okay. Many toys also have electromagnets inside them. So students, now from this animation video we are going to understand the electromagnet in a better way. Okay.
In this module, you will learn about electromagnets. You might have seen a crane lifting heavy loads of scrap iron. But how does a crane lift heavy loads? A crane has a strong electromagnet attached at its end. This electromagnet attracts all magnetic materials in scrap. You are introduced here to the term electromagnet. To find out what an electromagnet is, let us do a simple activity. For the activity, you need an electric cell, an iron nail, a piece of insulated copper wire, and some paper clips. Let us now start with the activity. Wrap the insulated copper wire tightly around the iron nail and attach its bare ends to the terminals of the battery. What do you observe? A current flows through the wire and the iron nail turns into a magnet. Now remove the connection. This will stop the flow of current through the wire and the nail will demagnetize. So, the iron nail behaves as a magnet as long as current flows through the circuit. Such a magnet is called an electromagnet. An electromagnet consists of a coil made from several turns of insulated copper wire wound on a magnetic material like iron. An electromagnet can be switched on and off and thus is also called a controlled magnet.
So students, I hope you understood how we can make an electromagnet and how does one works. Okay, we have also seen different applications of electromagnets in which it is used. Okay, now we are going to learn about electric bell. So students, electric bell is also one of the application of electromagnet. It has an electromagnet inside it. Okay, so it consists of a coil wire wound on an iron piece. As you can see in this figure, this is the coiled wire wound on the iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in the contact with the screw, the current flows through the coil, which becomes an electromagnet. It pulls the iron strip. In the process, the hammer at the end of strip strikes the gong of the bell to produce a sound. Okay, so now we are going to understand how does the electric bell works with the help of animation video. Okay.
Yes, most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. This is the inner structure of the bell. Let me first tell you the names of the basic components. This is a push switch, which is nothing but the switch we press when we ring the bell. This is a coil of wire wound around an iron piece. There could be two coils of wire wound around an iron piece as well. Remember, we've just drawn a simplistic version of the actual circuit. So it will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker which strikes this gong. That's when we hear the sound. So we can see that this is a circuit that can be formed. It's not complete. Why is it not complete? Well, we haven't pressed the switch yet. When we push the button, this circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts this soft iron towards it. And in the process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing.
So students, I hope that you have understood how the electric bell works. Okay, so we have completed this whole chapter. If you have any doubt, you can ask me. Okay, thank you.